Hi, so this is Deepak here, and we are at the Dead Sea with our supporters and directors of the Chopra Foundation, the Explorers Retreat. We're having a really good time, but we also want to kind of delve into the whole mystery of existence and why we're here, what does it all mean. So, I was looking at Ludwig Wittgenstein's quotes the other day, and he said the big mystery is not how the universe came into existence, the biggest mystery is that it exists. And so there are some very fundamental problems that scientists are looking at right now. What is the universe made of? How do we know what it's made of? What is the history of the universe? How do we know that? So before I give you the short history of the universe as understood by science today, I want to caution that the scientific model of everything is always being revised. So what we know today may not be what we know tomorrow. There are right now three fields of inquiry that are very important in trying to understand science. One is what we call cosmology. The second is quantum mechanics. And the third is relativity. And of course there's a fourth that preceded that, which was Newton's laws, classical universe. So it's a short time to give you everything we know about this model. And I want to caution, it's a model. Even Stephen Hawking in his book, Grand Design, with Leonard Malad who's one of my co-authors as well, they said science is a model. It doesn't actually give you the truth about reality. It creates a model because models are created by thought without knowing where thought comes from, and we'll discuss that later. Okay, so the history of what we know in cosmology is as follows. There was a Jesuit priest in Europe by the name of Lemaitre who had heard a radio show by Fred Hoyle, who everyone knows as the Hubble telescope, and Hoyle had described the steady state of the universe, etc. And actually Hoyle had coined the word Big Bang in a pejorative way. But when the Jesuit priest Lemaitre heard about it, then what he suggested was, since one of the observations through telescopes, now very refined as the Hubble telescope and the James Watson telescope, is that the universe is expanding, that the space between galaxies is expanding. So Maitre came to the conclusion, reasonable, that if it's expanding from something, what is expanding? So he worked backwards and he said it must have begun at some point as an infinitely small piece of matter or information or energy, smaller than the size of a dot, smaller than the period at the end of a sentence. And then he said that must have been Big Bang. So a lot of people kind of agreed with that, a lot of people disagreed with that, but they had no way of kind of coming up with a reconciliation of this observation. The universe is expanding, so it must have expanded to something. It must have started as something very small, and that small was the sudden appearance of what we call the universe in its seed form, like a sperm or an egg. And in fact, he used the analogy of the cosmic egg, which is, by the way, an analogy in great Vedic traditions also. It's called Hiranyagarbha, the cosmic egg. So this was fine, but there was no proof. Now, how does cosmology work? People come up with theories, and usually they come up with theories that are mathematical. Mathematics is astonishing. Eugene Wigner, who was a great mathematician, he said, why is mathematics unreasonably effective? Well, we don't know. But mathematics is in the human mind, in the mind of the mathematicians, and it's based on symbolic expressions of what is equal to what. Basically, every mathematical set is a set of equations. This is equal to that. So everything is equal to everything in a sense because everything is connected to everything else. But mathematics symbolically describes transformations or relationships. So the way cosmologists work is they come up with a theory, then they design an experiment, then they make an observation, and then they ask other people to make the same observations. If everybody agrees, then they say this works. Okay, so these days that's how cosmology is done. There are mathematical constructs, then there are experiments which can be done with big telescopes out in space. Hubble telescope, James Watson telescope. Every day there's a new telescope that is being put out on satellites, and then they make observations, they publish them, and if everybody agrees, then they say, well, this is probably true. Okay, that's how cosmology is done. And based on this, there was something that was discovered by scientists called cosmic microwave radiation. So if you've ever used, well, we all use television sets. You know, sometimes before the program comes on, you have this blurry on-off kind of radiation, basically, that is detected. It's in every television set before the program actually comes. That's cosmic background. That's going back to the Big Bang. Okay, so now scientists mathematically work backwards, and they say 13.7 billion years. I'm skipping over all the details, but 13.7 billion years ago, there was something called the Big Bang. It's a misnomer because it wasn't big and it did not bang. Okay, but nevertheless, that's the word, the Big Bang. And what happened is, out of nothingness, nothing. We can talk about nothingness later. What is the nature of nothingness? But out of nothingness, the universe was born. And the first 10 to the power of minus 43 seconds post Big Bang. So it's a very short time, right? 10 to the power of minus 43 seconds. It's a fraction of 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 a second. Is something that they call the Planck epoch. Planck epoch. For this small period of time, there are no laws to speak of. There's no matter, there's no energy, there are no particles. So what happened? What caused the Big Bang? Don't know. Now, some other time, when we have the time, I'll tell you all the theories that there are many theories of what caused the Big Bang. But despite all those theories, they are, again, mathematical theories. In mathematical imagination, there's no way to validate them. And the Planck epoch, 10 to the power of minus 43 seconds, since there's nothing to observe, we don't know what was there. In fact, it may be, according to many people, including Francis Collins, who's head of NIH. He's very interested in theology. He's a Christian. And he says it's unknowable what happened at that time. Not unknown, unknowable, because there's nothing to observe. Okay, there are no laws to speak of. Space-time, matter, energy don't exist. Okay, so that's the Planck epoch. Then there's something else that happened, which is called cosmic inflation. That's 10 to the power of minus 37 to 10 to the power of minus 35, which is, again, a very short period of time, where the universe, from that dot, it tripled in size every trillionth of a trillionth of a trillionth of a second. So from that dot, it became the size of a grapefruit. And then it slowed down. We don't know why. All this is mathematical, okay? That somehow these things happen. Okay, it slowed down, and then it's been expanding ever since, from the size of a grapefruit to what it is now. The cosmic horizon is 47 billion light years away from us. So we are, even though the universe is 13.87 billion years old, the horizon, which is the farthest from where we are sitting, is 47 billion light years away. So what's happening across the cosmic horizons? Galaxies are disappearing into the unknowable, because by the time when light comes from there to here, our solar system will not exist. It will have burned itself into the heat death of absolute zero, having exhausted its thermonuclear energy. In any case, if that cosmic inflation hadn't happened, the universe as we see it, with its distribution of galaxies, would not exist. So it had to happen, this short period, where it tripled in size every trillionth of a trillionth of a trillionth of a second. Now at this moment, going back to the Big Bang, again, according to current theories, for every billion plus one particles, there were a billion antiparticles. So there was a little mismatch. Why? We don't know. So billion plus particles, billion antiparticles, they collided, they annihilated each other, and the whole universe was permeated with photons, okay, which became what today we call electromagnetic energy, which we're using right now to go on Facebook Live. So that happened a long time ago. And the universe was filled with light, electromagnetic energy, and that slight imbalance created the first particles. And what were the first particles? Hydrogen and helium, most of which is still in interstellar space. Okay, so it took about 400,000 years after the Big Bang for the first atoms to get created in the crucible of stars. And then that happened through fusion. Hydrogen fused with hydrogen, and slowly more and more fusion, heavier atoms. And so the most predominant atoms in the universe are carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur, which make 90% of our body. So where did your body come from? It came from the stars. We are stardust beings that were forged in the crucible of stars and from different galaxies. The carbon in your fingernails, the oxygen going to your brain right now so you can listen to this lecture, they all come from different galaxies. In other words, it took the whole universe to conspire so we can have this conversation. Now, in this whole mix, cosmologists talk of what are called mathematical constants. We don't need to get into details, but things like the size, the mass of the proton, neutron, the ratio of the electromagnetic field to the gravitational field, many constants, including something called the cosmological constant, which Einstein described. Had these constants been off by a decimal point here or there, again, we wouldn't have this conversation. So what do scientists call this? They call this the anthropic principle. Okay, they don't like it because it means that the universe was designed for us by some cosmic intelligence. So there are two versions of this anthropic principle. One is called the strong anthropic principle. The universe was created for us. And the other is called the weak anthropic principle, which says, no, it just happens we live in a universe where the laws are such that we happen to be around. We hit the jackpot. There are many other universes where there are no beings like us. So that's the strong and weak anthropic principle. But there's another version, which I can talk to you about later, called chaotic inflation, which is basically we are the result of hitting the jackpot in a cosmic casino, a cosmic Las Vegas outside of space-time. I'll explain that to you at another session, but these are the theories competing for each other. Okay, so 400,000 years, the stars start to form atoms, and then the universe continues to expand. Where are we now? We are at the point where we know, one thing is for sure, that the space between galaxies is expanding, according to many scientists, faster than the speed of light. So the space is being ripped apart. By what? They call it dark energy. And that was Einstein's cosmological constant, which he later said was the biggest blunder of my life. But then there was a lot of controversy about this, but right now, even though Einstein later retracted his cosmological constant, it's back. Everybody thinks there's dark energy, which is 70% of the universe. So that leaves only 30% of the universe remaining. Of that, 26% is another mysterious entity called dark matter. And the reason it's called dark matter is it's invisible. And the reason it's invisible is that it's not atomic. So you're made of atoms, this is made of atoms, everything else is made of atoms, the stars are made of atoms, trees are made of atoms, iPhones are made of atoms, but dark matter is not atomic. So what is it? We don't know. We may never know because we can't see it. It doesn't interact with light. So it doesn't interact with light, absorb light, emit light, no relationship to light. So why do we even call it matter? Because usually matter is reserved for things like this, hard. Well, we call it matter because it behaves in a way that matter behaves. It bends space-time in the same way as regular matter, and is responsible for most of the gravity in a galaxy. So if it weren't for this dark matter, whatever it is, the solar system, the planets would spiral off into intergalactic space. You and I wouldn't exist. Galaxies would fall apart. What is it? Don't know. Right now there's a theory that there are some particles called WIMPs, weakly interactive massive particles, the theory, and people are getting Nobel Prizes for coming up with theories, but nobody knows what it is. It may indeed be non-existent. You know, dark matter, dark energy may just be mathematical constructs that fit into what is called the standard model of physics, what is called the core theory. You know, it's like, what do you say? You fill in the gaps. So you come up, because the regular theories without dark matter and dark energy can't explain what we think is the mechanics of what's going on in the universe. Well, that leaves 4% of the universe that's made up of atoms. Of that, 99.99% is invisible interstellar dust, which is mostly hydrogen and helium. So the visible universe with all the galaxies, all the stars, all the planets is 0.01%. 0.01%. The rest is unknown or unknowable. But here's the problem. Atoms are made of particles, and particles also have this dual nature. If you know anything about quantum mechanics, when you're observing particles, then they're particles. When they're not being observed, or when they're not being measured, or when they're not in interaction with other particles, they disappear into waves. And what are these waves made of? You know, because like right now we said, what are the waves of the ocean made of? Not that this is the ocean. They're made of water. What are sound waves made of? Air. What are the waves that make the universe made of? The best answer is they're made of possibilities. So then mathematical possibilities, where do they exist? The best answer is they exist in something called Hilbert space. Hilbert happens to be the name of a mathematician. Where is Hilbert space? Oh, it's a multi-dimensional infinite space. But where is it? The best answer is shut up and calculate. We don't know. Okay? So fundamentally, what's the universe made of? Nothing. So then if it's made of nothing, why does it appear like this? Why does it appear like this? Or the moon, or the sun, or the galaxies? As of 2 months ago, according to current cosmology, there are 2 trillion galaxies. That's almost a number that you cannot count with computers. There are 700 sextillion stars. 700 sextillion stars, and there are trillions and trillions and trillions and trillions of planets. In fact, just 3 weeks ago, scientists identified a solar system, and they've called it, now they've given it a name, TRAPPIST-1, and that solar system has 7 possible habitable planets like ours. So statistically now, there is almost certainty among scientists that there are trillions of habitable planets like ours. Will we make contact with them? Not through current technologies, because they're light years away. TRAPPIST-1 is 30 light years away from where we are right now, which means it takes light 30 years, light, traveling at the speed of 300,000 kilometers to get here, which would never happen for several generations. But, you know, scientists don't give up. They have technologies. They will learn to figure out non-local communication, and robotics, augmented intelligence. I don't like the word artificial intelligence, but augmented reality, and conceivably, we can see the stars and galaxies with humans by sending DNA and using robotics to reassemble through dust of other planets. Life as we know it will make contact with other life forms. That's all in the realm of mathematical possibilities right now. But basically, what's the universe made of? It's made of nothing. Why does it appear like this? That's the second problem in science today. The first problem is called the hard problem of what is the universe made of. You can Google this stuff, by the way, and you'll find information. The second problem is, how do we know what we know? In other words, how do we know we exist? Or how do we know this exists, even though it's out of that? That's even though it's made out of nothing. So that's called the hard problem of consciousness. Nobody can explain, as of yet, what consciousness is or where it came from. So consciousness is best defined as the knowing element in every experience. So right now we're sitting here, we know that we're here. Okay? So knowing element in every experience. Now two kinds of experience. One is perceptual experience. I can see that bottle, which is, by the way, a human construct, but that's another story. I can see, Punacha here. So that's a perceptual experience. Perceptual experience consists of sounds, tastes, smells, textures, colors, shapes, hardness, softness, etc. These are fundamental raw experiences that every conscious being has. Are they the same experiences that another species has? When the dog barks, does it hear the same sound that you and I hear when the dog barks? Probably not. It has a different brain, and so it computes information in a different way. What does a crow sound to a crow? I only know what it sounds to a human. So the consciousness of other species is not, we don't have access to it. Now, of course, if an animal looks pleased, we think it's happy, and we're probably right, but we don't know what it's experiencing. So this is called the hard problem of consciousness. Where is consciousness? Can we touch it, see it, taste it, smell it? Obviously not, because we can't see it, and yet without it, we would have this experience. So like the universe, the consciousness, which makes the experience of the universe possible, is also made out of nothing. So how does nothing interact with nothing to create everything? That's the big problem. And these are the two open questions. There are 125 open questions in science. Like, what's at the center of the Earth, for example? Most people think it's iron, and it's responsible for the electromagnetic field of the Earth. North Pole, South Pole, etc. There are many. How did life begin? So these are unanswered questions. 2 trillion galaxies, 700 sextillion stars, trillions and trillions of planets. Our solar system and the planet came into existence, according to all this computation, a little less than 5 billion years ago. About 4 billion years ago, the first life forms appeared on this planet. They are bacteria. They are called chemolitho-autotrophic hyperthermophiles. They are basically chemo because they're chemicals. Chemolitho lived on rocks. Autotrophic knew how to multiply themselves. Hyperthermophiles because they lived on the rims of volcanoes. So they are our ancestors. There's an unbroken chain from 4.5 billion years to where we are now, with not a single gap in the chain, not a single break in the chain. When did plants and other species emerge? 2.5 billion years ago. Reptiles, 300 million years ago. Mammals, 100 million years ago. Human beings, only 100,000 years ago. So now, according to some deep historians, there were 8 types of human beings up until 30 million years ago. 30,000, sorry. 8 types of human beings up until 30,000 years ago. So we are Homo sapiens, which means the wise ones, which is the name we gave ourselves. But there were Homo neanderthalis, Homo erectus, Homo florensis, etc., etc. And they were as different as a cat is from a lion is, from a panther is, from a cheetah is, from a tiger is. So completely different species, but the same family. So some were this big and some were this big and some were in between. They all looked like us, and they had only, their language, primitive language, was only danger calls and mating calls. Till one species, us, and the leaders of the packs, you know, these mammals, and especially hunting mammals, carnivores, they move in packs. Wolves move in packs, lions, tigers, they move in packs. Our species developed a language which was more than mating calls and hunting calls. And the first language was gossip. Okay? So and so is sleeping with so and so can't be trusted, so and so can be trusted. But as soon as we developed a language for storytelling, then we created constructs like money, commerce, nations, kingdoms, civilization. And we actually, the leaders of the pack became the strongest. They destroyed all the other leaders. So all the other species are extinct. Human language, that's why I was asking a question, is less than 15,000. Oral language, written language, less than 5. And refinement, even less than that, as we heard, 3,000 from the professor. And here we are. So this is a very short history of what the scientific model says at the moment. Lot of questions here, because if you don't answer the hard problem of consciousness, then the whole model falls apart. Because everything we know is based on a mode of knowing and then a story around that mode of knowing. You know, we construct these atoms, galaxies, particles are names we gave to modes of knowing and to modes of experience. So that's a short history thus far. We can explore this in detail later. Thank you.